Dear students, today we'll continue our practices on Mathematical Analysis 1, and the next topic is definite integrals. So now we will move to the new section. After indefinite integrals, we'll study now definite integrals. Okay, firstly I want to recall definition of definite integrals. So firstly, we need to give definition to integral sum. So let a function f of x be definite on the interval ab, and we have an arbitrary partition. For example, a it's equals to x0, x1, x2, etc. xn is equals to b. So any arbitrary partition we have on this interval, of course, on AP, we divide into n subintervals. You can see here we have n subintervals. A sum of the form, let's denote by Sn, sum I is 0 from n minus 1, f any psi e delta x e, we call integral sum of the function f of x on the interval ab, where psi e it is any point, arbitrary point between xi and xi plus 1, and delta x with delta xi with the node xi plus 1 minus xi. The difference, this is delta. So where I from 0 till n minus 1. Okay, now this is we call integral sum of the function. And now the definite integral, if we find the limit of this Sn, we'll get definite integral here. So this is not just it is definition of definite integral. So we have limit. So I will explain what is maximum delta x e tends to 0, and this sum e from 0 till n minus 1 f xi I and delta xi, and it's equals to definite integral ab. This is interval, yeah. We define our integral on the interval ab, f of x dx. So this is we'll get our definite integral by this way. So the limit of the sum Sn, provided that the number of subdivisions n tends to infinity and the largest of them, delta xi, tends to 0 here. And it's called the definite integral of the function f of x on the interval ab. Okay, now now we have methods of evaluating definite integrals. So the first one is a definite integral with variable upper limit. So if a function ft is continuous, first method, if a function f of t is continuous on the interval ab, continuous on the interval ab, then the function f of x equals to, from a to x, ft dt. F of x is the antiderivative or primitive of the function f of x. So where the derivative of capital F of x equals to f of x function. Yeah, for any x from the interval a, b. So this is the first method. The second method, so we'll use this second method. It is called Newton-Leibniz formula. So let me write Newton-Leibniz formula. So what we have, if primitive of f of x, the derivative of primitive is equal to f of x, then integral ab, definite integral ab, f of x dx equals to f of b, this primitive, yeah, minus f of a. So what we have here, the capital F is our primitive, and it satisfies this condition, yeah, and then the definite integral on the interval ab we can find by this equation. So this is f primitive, the value of primitive at the point b, minus the value of primitive at the point a. So this is definite integral. And let's consider an example here. So, for example, okay, find the integral from -2 till 5, for example, and 2x fifth degree dx. Okay, how to find this integral? By Newton-Leibniz formula. Firstly, we need to find what primitive of this function. So the primitive of this function is 2x 6^6. Yes? And we'll do it like this, -2, the stick, and 5. It means the upper bound is 5 and the lower one is -2. So we need to put to our primitive. So it means 2 times 5. Yes. Let cancel them. 1/3 we have just. Yeah, that's why. 3 here. 5 6 power, and minus what we have in the middle, we have minus fa. Now we need to put this one, the least one, yeah, it is -2. So -2 6 power over 3. We need to just compute this one now. So 5 6 power, this is 625 times 25 over 3, and minus here 2 6 power, it is 64 over 3. We need to just compute it and we'll get the answer. So in definite integral, we will not add constant because here we get exactly value of this integral on this interval AB. Is it clear? So this is not for all x. This is for exactly one interval AB. And here we will get exactly value of our integral. That's why we don't have any constant c. Just we subtract these numbers and we have answer. Okay. Now, let's consider the properties of definite integrals. So, properties. Okay, first one. Integral AB f of x dx, it's equals to minus, we can change our bounds here, our endpoints. So it will be minus integral b a f of x and f of x dx. So if we change it, we need to put here minus. We can change the limits. So the next one, second one, integral a f of x dx, this is 0. So if the upper and lower limits are the same, then there is no work to do, the integral is 0. Third one, integral ab constant c times f of x dx, it will be c times integral ab limits, f of x dx, where c is any number. So we can factor out a constant. The next one, fourth one. So integral ab f of x, or let write this one, plus minus gx dx, it will be ab f of x dx plus minus integral ab g of x dx. So we can break up definite integrals across a sum or difference. Next one. So this is one of the main ones. So integral ab f of x dx, it's equals to integral ac f of x dx plus integral cb f of x dx, where c is any number. So it means we can divide our integral to two integrals. So here see we can take from the interval AB. For example, it will be intervals AC and intervals CB. And this is useful, but note, however, that C doesn't need to be between A and B. Okay, now the next one, for example, if we have integral absolute value, so AB f of x dx, this is less than or equal integral AB f of x absolute value module dx. This is also the most important properties of these definite integrals. Here we have main properties of definite integrals. Okay, now let's continue solving examples. Let's consider the next example. Find the integral 0 to 1 for x minus 6 cubic root of x squared dx. So if you know how to find indefinite integrals, we can easily find definite integrals by the formula Newton-Leibniz. So here also the same work we'll do. Find firstly just primitive of this function. It will be 4x squared over 2, yeah, or just 2x squared, minus the next one is, this is x the power of 2 over third. If we add 1, it will be 5 over 3, so it will be 18 over 5 x 5 over 3. This is just primitive of this function. And here we have two limits, so it is 0 and 1. So now we need to put these values to our integral. So it will be now 2 times 1. The first one we need to upper limit, so 2 times 1 squared, yeah, minus 18 over 5 times 1, 5 over third squared. So this is the first one. And then subtract from this one the next one, so it is 0. When we put 0, here we have 0, here we have also 0, and so it is just 0. So the answer is 2 minus 18 over 5, or just it will be minus 8 over 5. This is answer. And let's move to the next example. So integral a1 minus 21 3 over e to the power of minus z minus 1 over 3 z dz. So here what we have, so we can write this one as minus 20 integral 1, and it will be 3 e to the power of z minus 1 over 3 z dz. So there's just, instead of x we have z, our variable is z. So now it will be 3, the primitive of this function is 3 e to the power of z minus 1 over 3. The next one is natural logarithm of z. Okay, So now minus 20 and minus 1 we have as limits. So it will be now just putting minus 1 firstly, 3 the power of minus e the power of minus 1, minus 1 over 3 natural logarithm of minus 1, and minus the next one, yeah? So we need to put 20, minus 20, 3 e the power of minus 20, minus 1 over 3 natural logarithm of minus 20. Okay, so now we have 3 e the power of minus 1 minus, so this is 0 now, yeah? It is 0 because natural logarithm of 1 we will get here. So this is 0. And now the next one is minus 3 the power e the power of minus 20. Then now it will be to double minus, we have plus 1 over 3 natural logarithm of 20. This is the answer. Okay, now okay, so the next example is with absolute value. Let's consider one example with absolute value. So integral from 0 till 3, absolute value 3t minus 5 dt. So how to find such kind of integrals? Here, if you put 0, it will be minus 5, yes? Our function with minus. We need to determine here where the quantity on the inside of the absolute value is negative and where it is positive. So how can we find it? Let's find here 0. So t 0 of this function is t is 5 over 3, yeah? Let me write here 5 over 3. If t is greater than 5 over 3, the quantity inside the absolute value is positive. And when t is less than 5 over 3, the quantity of inside of the absolute value is negative. So now using the properties of definite integrals, so we can write this integral like integral from 0 till separately 5 over 3 and this function 3t minus 5 dt, and the plus next one 5 over 3 0 3t minus 5 dt. So we can divide our integrals. Now what we have here now, however, we said that where it is in this case it's positive and in this case it's negative, so it will be now we can write 0 5 over 3, and however this is negative, so putting minus and opening this bracket dt, and the plus integral 5 over 3 0 3t minus 5 dt. And now let's compute this integral. Sorry, here not 0 3, yeah, the upper bound 3. So and now let's find this integral, definite integral. It will be now minus 3 t squared over 2 and the plus 5t on the interval 0 till 5 over 3. And then next one is plus 3t squared over 2 minus 5t on interval 5 over 3 and 3. Let's find the value. So it's equals to minus 3 over 2 times 5 over 3 squared and plus 5 times 5 over 3. And when we put 0, it will be 0. Okay, now next one is plus 3 times 3 squared. Yeah, firstly putting this and the minus 3 over 2, of course, here, and the minus 5 times 3, then minus, let's put now list 1, so 3 over 2 times 5 over 3 squared and minus 5 times 5 over 3. Okay, now when we compute them, we have here, they are cancelled, 25 over 6 and other ones are, so we can add them, and after simplifying we have here 8 over 3. When we add, it will be 41 over 6. So this is answer. And now let's consider one example with using substitution rule. So find the integral minus 2 0 and 2t squared 1 minus 4t cubed dt. Okay, let's try to find this integral. So here we need to use the substitution rule. Let denote by, let write here x, not t, x, okay, and then let denote by t our expression 1 minus 4x cubed with t. Okay, so we denoted our 1 minus 4x cubed with t, and now let's find dt. So dt is minus 12x squared dx. 12x squared dx. So it means x squared is dx over minus 12. Dx over minus 12. And plugging into this into the integral, given integral, what we have here. And now note, so t is dt over minus 12, sorry, here. Or we can write like this, so x squared dx, here dx also, dx, it is dt over 12 with minus, of course, dt over 12. And now, so look here, our x is changing from -2 till 0. Yeah, from -2 till 0. And x changing from -2 till 0. And now, what will be the intervals for new variable t? So now t, when we put -2, when we put 0 here, when we put 0, it will be 0 and 1 we have here. Yes? If we put 0, it will be 1. So it will be 1. So it is 1. And now, when we put -2 here, we have -2 cubed. This is -8. It will be 32 plus 32. And we have 33. Look here. Now our t changed between 33 and 1. But we can change our limits, yeah? So now we have like this 33, 1. And here we have x. Where is it? X squared. It is like 1 over 6 with minus here, minus 1 over 6 because 12, and we have 2 here. So minus 1 over 6, and they gives to us dt. But this one is t, square root of t, dt. But it should be by the increasing order, not decreasing. So we need to change our bound. So it will be now when we change from property which we started, so it will be here minus will be plus now. 1 over 6 from 1 till 33 square root of t dt. Square root of 3 dt. And now let's put this values. So we have 1 over 6. Now our primitive is it is t 3 over 2, 3 over 2. Yeah, so it will be now 1 over 9, and the integral, well, in interval 1 33. So 1 over 9 t 3 over 2 power from 1 till 33. And when we continue it, it will be 1 over 9. So t, our t is 33 now. 33, the power of 3 over 2. And minus 1. Minus 1. Or we can write 1 over 9. 33. 33 minus 1. This is final answer. So we changed our variable, we substitute, and we need to substitute our bounds, also our limits on the interval. Let's consider the next example. So find the following limit, integral. So integral 0 natural logarithm of 1 plus p e to the power of x cosine 1 minus e to the power of x dx. So we need to find this integral. Okay, so firstly, let's substitute as t 1 minus e to the power of x. And then we have dt is minus e to the power of x dx. Yes? Okay, now let's find now the bounds for x and for t, I mean. So x is changing from 0 till natural logarithm of 1 plus pi. So now our t changes. If we put natural logarithm of 1 plus pi here, it will be natural logarithm 1 plus pi. If you put instead of x, it will be 1 plus pi and 1 minus 1 plus pi. So it is just minus pi. So we have it like this: 1 minus e to the power of natural logarithm 1 plus pi. So it means it's equals to 1 minus 1 plus pi, or just minus pi. Yes? So this is minus pi we have here. And if you put 0, it will be 1 minus 1. It is just 0. It's just 0. We'll get 1 minus e to the power of 0, or 1 minus 1, just 0. Okay, now let's continue now. And what we have here, we have integral. So now from 0 till minus pi, and now dt is minus e to the power of x. Yeah, so we have here minus, and cosine t dt, cosine t dt. And when we change our bounds and when we write on the increasing order, so we will get here minus 1 minus, and with the second minus, it will be plus integral from minus p till 0 cosine t dt. So it will be now sine t minus p and 0. Minus p and 0. It will be sine 0 and minus sine minus pi. So sine minus pi, this is also 0, this is also 0. It is just 0. So we have two methods. We can substitute our variable and find primitive, and then put given one, so when before the substitution, and then putting just this bounds. Or we can directly change our bounds, our limits, and find value. Let's consider the next example. So integral, find the integral 0 pi over 2 x squared sine x dx. Okay, so what should we do? Firstly, we need to use here integration by part. 2 times we will use it. So we consider such kind of examples. So if we use 2 times integration by parts, we'll get the answer here. So firstly, let u is x squared, du is 2x dx, and sine x dx, it is v dv, it is dv. So v is minus cosine x. And so uv, it is minus x squared cosine x. And we have here now bounds 0 pi over 2. We need to write like this. And the minus integral, but here we have minus, that's why it will be plus integral with 2 x cosine x dx from 0 to pi over 2. Continue. So now what we have here, if you put pi over 2, here, the cosine pi over 2, this is 0. And when we put 0, this one will be 0, the first one. So the product is 0 for these two values. This is 0. 0 plus the next one now. 2 integral 0 pi over 2 x, let me rewrite, and then we'll open it, cosine x dx. So here again, x is u, dx is du. So cosine x dx is dv. So v is just sine x. Okay, now it will be 2, and now uv, so it is x times sine x, x times sine x, and 0 pi over 2, yeah, the bounds. So minus integral sine x dx, and here also 0 pi over 2. Do not confuse, we need to put these limits. Okay, now let's continue. And here we have, if you put pi over 2, it will be just sine pi over 2, it is 1. So we will get 2 pi over 2. When we put 0, we have 0 pi over 2, and this integral, yeah, so it is minus, but here we have when we integrate sine x, it will be minus cosine x, yeah, so it is just plus cosine x with limits 0 pi over 2, and here 2 pi over 2. So when we put pi over 2, it will be 0, and when we put 0, it is minus 1, but it will be with minus, yeah, in the middle it will be minus, or pi minus 2. This is final answer. Let's consider the next example now. So find limit 0 pi over 4 cosine square x dx. So here, firstly, what should we do? Firstly, open this x square, yeah, and so we have pi over 4, sorry, and it will be 1 plus cosine 2x over, reduce the power, over 2 dx. It will be now, we can write easily like pi over 4, 1 over 2 plus cosine 2x over 2 dx. Or when we continue, we have 1 over 2x plus, so 2 and 2 are, so 1 over 4 we'll get here. and it will be sine 2x. Sine 2x. And here we have bounds 0 and pi over 4. Okay, so now we need to put the values. So it will be 1 over 2 times pi over 4, yeah, and plus 1 over 4 times sine 2 times pi over 4. And when you put 0, it will be 0 minus 0, and this is also sine 0, it is also 0 minus 0. Okay, so we have pi over 8, and it will be pi over 2, it is 1 plus 1 over 4. This is final answer. Let's move to the next example. So integral, and limits are e and e squared dx over x natural logarithm of x. So here we have x, yeah, so this 1 over x, we can write in differential, in the inside of our differential, so it will be d natural logarithm of x we can write, because if we find derivative from natural log, it will be 1 over x, and here natural logarithm of x again. So what we have here just the function as 1 over x. Our integral depends on natural logarithm of x. That's why we have just 1 over x, dx over x, I mean. Dx over x, this is natural logarithm of x, so it will be natural logarithm of x. And the limits are e and e squared. So it will be natural logarithm of natural logarithm e squared minus natural logarithm of natural logarithm e. Now it's equals to, it will be 2, yeah, natural logarithm of 2, and here we have it is 1, natural logarithm of 1, it's just 0. So the answer is just natural logarithm of 2. Let's consider the next one. So integral, and limits are 0 and 1. So x cubed over x8 plus 1 dx. Okay, so let's consider this example. Here also we need to use this differential, and using differential we can write this x cubed in differential as x fourth degree. So it will be dx fourth degree, but here we have 1 over 4 coefficient, because when we take derivative from x fourth, it will be 4x cubed, but we have here just x cubed. That's why we need to divide by 1 over 4 also, and over x fourth squared plus 1. So what is it now? This is now integral with respect to x fourth degree. With respect to x fourth degree. So, and in this case, we compute this integral as arctangent. Yeah, the primitive of this function will be arctangent. So it will be now, it's equals to 1 over 4 arc tangent x fourth degree. Yes, of course. And bounds are 0 and 1. So the answer will be now 1 over 4 arc tangent 1 minus, let's factor out. So, and here we have arc tangent 0. So arc tangent 1, what is it? It is pi over 4. Yeah. So pi over 16, and arctangent 0, it is 0. So it's just pi over 16. And now let's consider the next example. So find integral 0, 1 x dx over x squared rational function plus 3x plus 2. So we consider such kind of examples when we find indefinite integrals. So to find definite integrals, firstly again we need to find indefinite integrals here, and we will find it with the decomposition of fraction, so dividing to elementary fractions, and it will be we have, let me write separately, x over x squared plus 3x plus 2 to be clear. So it's equals to a over, here we have, we can divide by this is like x minus 2, x plus 2, and x plus 1, because the roots of these quadratic polynomials are minus 1 and minus 2. So it will be a over x plus 2 and plus b over x plus 1. And now, hence we'll get here x plus 1, x plus 2. So a times x plus 1 plus b times x plus 2 equals to x. Now, when we put, instead of x minus 1, we'll get here 0, and this is just 1. B is minus 1. So when we put, instead of x minus 2, so here we have minus 1 minus a, and here we have 0. This is a minus a is minus 2, or a is 2. So a is 2, b is minus 1 we have. Let me one more check. Yeah, x, when x is minus 1 and this is 0, this is 1, so b is minus 1, correct. And when x is minus 2, it is 0, it is minus 1, minus a, minus 2, correct. Now let me write our integral. So our integral is equals to 0, 1. So x, now we can write as 2 over x plus 2 plus, or minus, here minus 1 over x plus 1 dx. Yes, okay. Now it will be 2 natural logarithm of x plus 2 and minus natural logarithm of x plus 1. So, and now we have these limits 0 and 1. When we put 1, it will be 2 natural logarithm of 3 minus natural logarithm of 2. And when we put 0, minus, it will be 0, 2 natural logarithm of 2, and minus natural logarithm of plus it will be now, but it will be 0 because natural logarithm of 1 will have. So this is 0, and we can add these two ones, and we have 2 natural logarithm of 3 minus 3 natural logarithm of 2. This is final answer. And now we'll move to the section application of definite integrals. So one of the application is finding area, especially area between curves. So For example, we have two curves. Y is f of x, and the next one is y is g of x. So we have two curves on the interval AB. It's definite, and assume that f of x it's greater than or equal to g of x. So it looks like this graph I tried to show it, and so for example we have any function f of x and any other function g of x. So on the interval AB, let we consider them. This one is B, let it is, and this is let A. Yeah. So on the interval AB, we have between these two curves region. Yeah. And we can find the area of this region. This is f of x. This is g of x. So this is application of definite integrals. And how to find this area? The area, let denote by S, and it will be integral AB. So we need to, from upper function f of x, subtract the lower function g of x dx. This is finding area. Formula of finding area. With respect to x, O, x here, of course. This is first case. And the second case, we'll consider now area between two curves with respect to x or y. So, for example, if we have two functions, x f of y and the x g of y, with respect to y, now we need to consider. And on the interval CD, where f of y is greater than or equal to g of y. And now, on this case, we have the next picture. So it will be now two functions. Yeah. So for example, here we have f of y, and here we have, for example, g of y. So this is x is f of y and x is g of y. So this point is D point, and this one is, yeah, this is C point, C, D. So we have again what? Region between these two curves, f of y and g of y. Now we need to find our integral with respect to y. So in this case, the formula is integral CD f of y minus g of y dy. This is for the second case. So, in the first case, again, here, this is second case. On the first case, we need to subtract from upper function to lower function. On the second case, we need to subtract from right function to left function. And let's consider example. Okay, example number 1. Determine the area of the region enclosed by curse. Y is x squared and y is square root of x. So let's try to firstly draw the graph of this function. So on the interval, it's given interval or not? No, we need to find firstly the interval. How to find? To find our interval, we need firstly equate these two functions. So x squared equals to square root of x. So it will be x force is x, or the roots are here 0 and 1 because x cubed minus 1, it is 0. Now x is 0 and x is 1. So the real roots here 0 and 1. So it means they are intersect the point 0 and 1, and it will be the intervals for integration, for definite integrals. So this point is 0 and 1. Let's draw the picture. So when 0 it is 0, when 1 it is 1 again. So the first parabola it is, yeah, like this. So it is x squared. And now, and it's growing. The second function, so square root of x. This is the graph of x squared. Sorry. And now square root of x you need to find. So it will be the graph of square root of x like this one will be. Yes? So now the region enclosed by this curse, it is this one. So we need to find here the area of this region. So we need to integrate on the interval 0 and 1. So s equals to integral from 0 to 1. So which one is upper one? Square root of x, of course. Square root of x minus x squared dx. So if we continue, it will be x. This is 1 over 2, yeah, degree. So 1 over 2 plus 1 over 1, it will be 3 over 2 over 3 over 2 minus x cubed over 3 on the interval 0, 1. So if we continue, it will be 1. It is 2 over 3 now. And we here minus 1 over 3. And when we put 0, it becomes to 0. Answer is 1 over 3. So our area is equals to 1 over 3. And now let's consider this next example. So second example here. So find the area of the region bounded by y is 2x squared plus 10. Then y is 4x plus 16. X is minus 2. And x is 5. So firstly we need to draw the graph. So it will be, look here. So this is what we have. It is minus 2. X is minus 2. So if it is 1 and 2, here minus 2 we have. So we need to bound with this line and 5. 1, 2, 3, 4, 5 here. Yeah, we have 5. So they are bounds. And we have also these two functions, 2 squared plus 10 and 4x plus 16. When x is 0, it is 10. So this is we have the least value is 10. Let me change a little change. Example to draw here. So it will be just 2x squared plus 1, for example. And if we change, I think it will be, and if we change here 4x plus 1, let 10, okay. And let's take a scale a little different with x or x. So here, for example, we have 10. For example, here we have 10, and yeah, the scale is different with x or x, but it will be bigger. That's why I need to take here 10. And the next scale, for example, if it is 10, for example, this one is 20. And now, so for x plus 16, it will be if x 0, y is 16 here, for example. And when x is 1, for example, it will be 20. So it looks like this function. Approximately, we will draw it. This is straight line, and we have here parabola. Our parabola is like this parabola. So this is our parabola. And now look here, we have 5 here, yeah? So we need to take the bound here. So, and here also we have bound. And what regions? We have 3 regions. This first region, second region, and third region. This is 5. Okay, so now have to find now these 3 integrals. So it will be integral. I will write just this expression, and you will compute this integral. So the first one is from -2 till -1. They are intersect in the point -1. From -2 till -1. So the higher function will be, upper function will be parabola plus 10 and minus straight line dx, plus we need to divide by to 3 integrals. The next integral will be from -1 till 3. This point is 3. So here the upper function is straight line, this one, yeah? 4x plus 16 minus 2x squared plus 10 dx, and plus the last integral. So here we have from 3 till 5, and which was the upper one, parabola again. So it is 2x squared plus 10 minus 4x plus 16 dx. So we need to compute this integral, and then we have the area of this region. Sum of these integrals will be the area. And similarly, you can find area with respect to x or y also, when your function with depends on y. For example, let's consider one more example here. So x is minus y squared plus 10, and x is y minus 2 squared. So here, Firstly, we need to find intersection points, and it will be, we need to query these two functions, and here we'll get y is -1 and y is 3. We have bounds, yeah. So the graph of our function looks like here we have two parabolas, so with respect to x or y, but so the first one, for example, it will be this one. I mean, this one is -y squared. That's why it is, for example, if it is 10, yeah, it will be like this. So the parabola going to the left side. And now the second one to the right side. Here we have 2 is 0 point. If it is 2, for example, it will be like this parabola, and like this, yeah. So we have two parabolas, and we need to find the region between them. So it means we need to subtract from right function left function. So the right function is here -y squared plus 10. So integral now, s is equals to integral. Bounds are -1, 3, and right function is -y squared plus 10. And subtract left function. Left function will be this function, y minus 2 squared, and dy. When we compute this integral, we have here, so this is very easy to compute, and it will be -1, 3, so it is -2y squared plus 4y plus 6 dy. And after finding primitive, it will be -2 over third y cubed plus 2y squared and plus 6y. Then -1, 3. So the answer is here 64 over 3 we'll get. This is final answer area. So I think it's clear with area between two curves. So it was the last example for today. If you have any questions, you can write on discussion group. And next time we'll continue our practice with improper integrals. See you later. Thank you for your attention.